Hello students, Miss Slyman here. I've got another applied context for you. So let's start by reading this problem with our highlighter. So we've got this problem that it's about shoppers on Black Friday, the day after Thanksgiving, and we have this function. I care about the units. So total number of shoppers entered the store T hours after the sale begins. Well, our sale started at 4 a.m., so beginning time, time 0 is 4 a.m. And when the sale starts, there's no shoppers in the store. I can see that also because S of 0 is 0, so I also see that in my function. Down here, I'm asked for a function that gives the rate, so that tells me I'm going to want to find S prime of t. And then in this next one, the rate shoppers are entering at 7 a.m. So 7 a.m., I know that that corresponds to 3 hours after the sale ends. So that's time equals 3. Sorry, after the sale starts, not when it ends. Down here, they've given me the rate. So this is already a rate function. And people leave the store T hours after the sale begins. So my units for this are going to be people per hour, people leaving per hour more specifically. The rate at 7 a.m., well, that's just going to be L of 3. Is the number of shoppers increasing or decreasing? How do you know? So I'm going to answer this question and give a reason. Now I want to write a function. So write a function, h of t, that gives rate, which the number of people in the store is changing. I'm going to graph my function. I'm going to look for positive values and negative values. I also see a window they've given me, so I'm going to use that when making my sketch. So I'm going to think about these values. At what times, if any? So maybe there's an answer, maybe not. The rate at which people enter the store is the same as the rate at which people leave the store. All right, so let's go back and put some numbers with these ideas. So S prime of t, well, that's a polynomial. Half of 4 is 2. So that'll be 2t cubed minus 48t squared plus 288t. So I want to find the rate at which people are entering the store at 7 a.m. So I want to find S prime of 3. So let me go into my calculator here. And let me clear. So let me clear everything. There must be a shortcut way to do that. Let's see here. Clear history. All right. So let me put in my values. So 2 times 3 to the third minus, get out of the exponent, minus 48 times 3 squared plus 288 times 3. And I get 486. I don't need to show any other work than this, but I do need my units. So that's people entering per hour. All right. This already is a rate, so people leaving the store. I'm just going to go ahead and put this in my calculator. Again, not showing any other work besides the left-hand side there. So negative 80 plus 4,400 divided by this polynomial. So I'll have 3 squared minus 14 times 3 plus 55. And I get a rate of 120 people leaving per hour. So is the number of shoppers in the store increasing or decreasing at 7 a.m.? Well, I have 486 people per hour entering, 120 people per hour leaving. So my number of shoppers is increasing because S prime of 3 is greater than L of 3. That implies that the number of people is increasing. In general, a function that gives the rate at which people entering the store is changing, well, that's going to be the rate of people entering minus the rate of people leaving. So use my calculator to graph that. Let's go into my calculator tab. And then let me clear out what's here. All right, so S of t is 2 times, I'm going to use x here. It's 2 times x cubed minus 48 times x squared. And I'm using the time sign just because I want to be really specific with my calculator. I want it to know exactly what I'm doing. I'm going to subtract my whole L of t here, so I'm going to use parentheses. And then I've got negative 80 plus 4,400 divided by x divided by that quantity, x squared minus 14 times x plus 55, close parentheses twice, and graph. I was given specific values for my graph, so I'm going to go in and edit my window. So I want my window settings. I'm going to go from 0 to 12. I'm going to go from negative 400 to 400. And there's my graph. So you would sketch that on paper. I'm going to cheat a bit and do a screenshot. So here's my picture. Okay. And then let me, okay. So positive H values indicate that if this is positive, so positive implies that my S prime of t is greater than L of t, which means the rate of shoppers entering is greater than the rate of shoppers leaving, which means that the total number of shoppers is increasing. Negative values mean that the rate of shoppers entering is less than the rate of shoppers leaving, which would tell me that the number of shoppers is decreasing. And now it says, what times, if any, is the rate at which people enter the store the same at which the rate of people are leaving the store? Well, S prime of t equals L of t. That implies that I have x-intercepts. So I can see that there's an x-intercept here. So I'm going to go back to my calculator and I'm going to figure out what that is. So I'm going to move this label, menu. I'm going to analyze my graph. Let's try that again. Analyze my graph. I'm looking for a 0. My left bound is on this side. Right bound is on this side. Here's my 0. I can take that and store it as some letter. I'm going to say enter. The reason that I want to do that is if I come over here, now I can push my letter A and get more decimal accuracy. You always want to have at least 3 decimals. So 5.545. What did I say? 5.545. So and our units there were hours into the sale. So that would be at what time? I want to make sure and answer the question of time. So my sale started at 4 a.m. So this is going to be at 9. So I'm going to subtract the 5 hours. And then I'm going to multiply by 60 to get my minutes. So at 9:32 And that's really at about 9:32, because the exact time is going to go on to have more seconds. So it's at about 9:32. The rate at which people entering and leaving is the same. And I know because that's where my x-intercept is.